Ever think about what happens to a billion years of Earth's history? Imagine finding a huge hole in the timeline of our planet, a mystery so deep that it makes us question everything we think we know about natural history. Today's video will go into great detail about the mystery of the Great Unconformity. You know how frustrating it is to lose something important if you've ever been desperately looking for your lost car keys or sifting through a messy room. Anxiety and confusion can be too much to handle, whether it's with your phone, cash, or even your drive. But the huge mystery of what happened to a billion years of Earth's past is the biggest one of all. This huge hole in Earth's history is called the Great Unconformity, and it's a geological mystery that makes experts wonder how Earth's history can be explained. To understand how important this event is, you need to know that a billion years is almost a quarter of Earth's history, which is a time frame that is missing from the fossil record. How to read the geological record? Before we can fully understand how huge the Great Unconformity is, we need to learn about the geological processes that make up the sedimentary layers that cover our world. Picture going outside with a shovel in your hand, ready to start a trip into the crust of the Earth. The history of each layer you dig up is different. For example, you might find a cassette tape from the 1990s, a dance ball from the 1970s, or even coins from the Roman Empire. This trip through the layers of rock shows a basic idea. Over time, things made by people and animals alike get buried under new levels of sediment, keeping pieces of past times alive. In the slow process of sedimentation, things are deposited and then stuck together. Mineral bits build up over thousands of years and slowly harden into sedimentary rock. As this geological symphony plays out, organic matter like bones, shells, and fossils become buried in the shifting layers, preserving frozen images of past life forms. Scientists can piece together a story of evolution and changes in the world that goes back millions of years by studying things very carefully. What unconformities are? However, the natural record does have some flaws. Earth's past is not a straight line. There are breaks in the flow of sedimentation, caused by changes in the environment or erosive forces. These breaks, called unconformities, show up as big holes in the rock record, like pages that are missing from an old book. Each unconformity marks a different time period of upheaval and change, when the Earth went through big changes that left behind mysterious signs of its troubled past. The Powell's Great Unconformity is the most interesting of these geological puzzles. This huge gap in history goes across countries and includes more than a billion years of missing events. The Great Unconformity was found in the Grand Canyon's vertical stratigraphy. It doesn't fit with the usual theories and makes us question how Earth's geology has changed over time. Powell's Great Unconformity is a geological wonder. Powell's Great Unconformity, which is in the famous Grand Canyon, is a great example of how complicated Earth's natural record is. Here, the Cambrian sandstone suddenly rises on top of the much older Vishnu schist, showing a huge gap in time. This change in layers shows a time span of more than a billion years, during which a big part of Earth's past is still unknown. The finding of the Great Unconformity leads to more questions about what it means. What happened that this amazing thing was left out? Why does our natural timeline have such a big hole in it? The answers to these questions are not just for fun. They have huge effects on how we think about Earth's history and the forces that have shaped it. Theories about what caused the Great Unconformity. A lot of different ideas have been put forward about where this mysterious gap in the geological record came from. Another popular theory says that a huge disaster, like a snowball Earth situation, might have played a big part. This idea says that when glaciers were very active, they scored the Earth's crust, wiping out huge chunks of natural history. As the world warmed up, new eras of life and evolution began. But the records of the old ones were lost in the ice. Another idea says that the Great Unconformity might be caused by tectonic action. The shifting of Earth's plates may have caused large amounts of erosion or the lifting of older layers, hiding signs of past geological periods. Because the Earth's crust is active and always changing, it's even harder for us to figure out how these unconformities formed. Discoveries and implications for geology. The Great Unconformity is more important than just being interesting. It is a very important piece of information for putting together Earth's scientific history. Scientists who study the layers of rock and sediment can find patterns of changes in the climate, mass extinctions, and changes in biodiversity. Each layer that is dug up may hold information about the weather and climate at different times, which helps us learn more about Earth's complicated past. Geologists who study unconformities also have to rethink how they study stratigraphy, which is the study of rock layers and how they are arranged. Scientists can improve their models of Earth's past and learn more about the processes that shape our planet by looking at the Great Unconformity and other geological features around the world that are similar. What it's like to face the unknown. Even after hundreds of years of scientific research, the real nature of these unconformities, especially the Great Unconformity, is still unknown. With each new finding, the puzzle gets more difficult, leading to more research and guesswork. Scientists are getting closer to finding the secrets hidden in Earth's rocks as they use more advanced tools and technologies. But there are still a lot of questions. How do we fit the billion years we don't have with what we know about evolution and how the world changes? When we study the Great Unconformity, what can we learn about what will happen in the land in the future? These questions show that scientific research and the search for information are always going on. How science and technology work together. Technology progress is very important in the search for understanding the Great Unconformity and what it means. Scientists can look at rock layers with a level of accuracy that has never been seen before thanks to modern tools like high-resolution images, geochronology, and isotopic analysis. These tools make it easier to find small changes in the chemical makeup and patterns of sedimentation, which gives us information about past landscapes and climates. For example, scientists can use isotopic dating to find out how old rocks and skeletons are, which helps us better understand when certain events happened. Scientists can tell a fuller story of Earth's past by putting together information from different fields, such as paleontology, sedimentology, and geochemistry. What uncertainty means for philosophy? The fact that the Great Unconformity exists brings up deep philosophical questions about what it means to know and understand. We can only understand so much because there are huge gaps in our scientific record. We fight to find lost keys all the time, and scientists do the same. They try to make sense of the chaos under our feet by studying the natural world. The Great Unconformity is a metaphor for the unknown. It's a way of saying that some parts of Earth's past are still a mystery. It pushes us to be open to uncertainty and understand that information is often more of a journey than a goal. There are many questions that come up when you try to understand something, but it is these questions that drive scientific inquiry. The Great Unconformity as a way to see the past. In the end, the Great Unconformity is proof of the mystery that our planet's past still holds. It has been there for a billion years and has been silently watching Earth change. It holds all the deep secrets that lie below the surface. We learn more about Earth's past and our place in it as we continue to study the complicated geological record. This natural event makes us think about how all life on Earth is linked and reminds us that our time here on Earth is very short compared to the planet's long history. We are still committed to understanding the complex web of life that has formed over billions of years as we try to figure out what the Great Unconformity is all about. The mystery of the Great Unconformity shows how science, technology, and our desire to learn are all connected in interesting ways. As geologists learn more about Earth's past, they find layers of complexity that make it hard to believe what we think we know about time and evolution. The Great Unconformity is a reminder of the riddles that still need to be solved and a record of a billion years of history that has been lost. At the end of the day, the journey of finding and exploration never ends. We get closer to understanding the complex tapestry of our planet's past with each new discovery and new technology. With its quiet but powerful story, the Great Unconformity will continue to inspire scientists and explorers for generations to come. It reminds us how important it is to be curious, ask questions, and keep seeking knowledge. If you found this exploration of the Great Unconformity as fascinating as we did, don't forget to subscribe for more intriguing insights into Earth's mysteries and the wonders of geology.